So now we have studied the extension versus timestamps graph, and the observations we got is that is slightly like y is equal to mx thing and all the things. Now we should move on to the forces extension graph. So so for this also the same thing which we have done in the before steps means how what are the steps we have executed here means all these steps are common means how many time steps and the TCL frequency and what are the output files we are getting for the three simulations and all the common things and getting DA underscore DA dot DAT file also common thing. And now we just need to compare forces extension. So that's the thing. And we can use the dat file create and timers extension profile as a combination of 3D underscore SMD underscore TCL dot out file, which I have already said to you. And after that, to get the graph, we should execute server explore force extension dot TCL graph to get the file to get the graph. So this is the graph. This is the graph. For my molecule. So here the x-axis is the 75 to 91, which is the end-to-end distance of the protein. Um, End-to-end distance of the protein while going through the means what should I say through the force which we are applying. So here the interesting thing you can see is starting the force is somewhat negative. So why the force is initially some negative? So so that is also one interesting thing. And the next we can see that the extension has done gradually by increasing force and by not sudden expansions. So let me say you one thing. My molecule is not what should I say, my molecule is not very similar to the other people molecule means I have seen some other person's molecule which is like this means it is completely folded and it has so many bonds, so many hydrogen bonds. So for that, yes, for that, so for other people graphs, some people's graphs is like this means while we are applying force to on the molecule, there is no expansion. There is and the graph is like this, and suddenly the force will be maximum, and the extension will also be the maximum. My molecule is very easy thing, and easy thing means having lesser bonds. So observation is we can see that the extension has done gradually by increasing force and by no sudden expansions. It slightly looks like a parabola, more of a straight line. So we can see that from the starting onwards, that the molecular protein is small. There is no need to apply great force to break bonds. So that's why force applied from starting onwards is usually for expanding the molecule or for unfolding purpose. Thus, we have that straight line type graph. Although there are smaller number of bonds, this protein has lesser number of bonds to break. This is observed because initially the unfolded protein has hydrogen bonds, van der Waals forces, etc. To break this bond, initially some force has to be given. That's why the force you have seen as negative. So once the bonds break the velocity, and then the force cancellations are not there. Means for cancelling the hydrogen bonds. So once the hydrogen bonds and van der Waals force are not there, the force which we are applying uh, will be very higher. Means suddenly you can see this increase, and when the force is very increasing, and you can get the maximum expanding thing. So once the bond break the velocity steeply increases, which leads to increase in the force after a distance 80 angstroms. 80 angstrom means after the slight increase. So that's it from the analysis of forces extension graph.